Hello guys, and welcome to the World of Genetics. Today the topic of discussion is transcription when it pertains to prokaryotes. Transcription uses DNA as a template. Before we get any further, this is what a transcription bubble looks like. Prokaryotes are considered polycistronic mRNA, which means they can encode several different proteins. Before we go any further, let's talk about the stages of transcription. Transcription stages are template binding, chain initiation, chain elongation, and chain termination. RNA polymerase makes phosphodiester bonds on ends 5 to 3 join nucleotides together. The core enzyme, which is alpha and 2 betas, and then you have the hollow enzyme, which is alpha, 2 betas, and a sigma. And the sigma factor is very important. Before we start with the steps, we must go over consensus sequence. It is a sequence that describes the nucleotides that are most present in a segment of interest. And these is what it would look like. Now let's go to the promoters. For the promoters, you have an upstream and a downstream. And the upstream is the sequences that happen prior to the start of transcription. And then you have downstream, which are sequences that start after the start of transcription, which is up, +1 and up. You have control regions in the prokaryote promoter, and this is the PRIBNAL or the Theta box that is located at -10, and then you have a -35. RNA polymerase binds DNA at consensus sequences to the promoter, and this helps aid in the start of transcription. For template binding and initiation, you have the core enzyme and sigma join together and then bind to the promoter. This causes the DNA to separate and form a transcription bubble. Afterwards, you have the sigma that leaves after about 9 to 12 nucleotides join to form the mRNA. And then afterwards, you have an elongation that occurs on ends 5 to 3 only after the core enzyme. You have two different repeats when it comes to prokaryote transcription. You have direct and you have repeat. Direct is directly just copying each other, and inverted is how you get to the hair loop when it comes to the RNA. And so for the termination, you have two different ones. You have a row independent and you have a row dependent. And for the row independent, you have the inverted repeats, which causes the hair loop. And these basically loops cause that signal for termination to end, and what happens is you'll get a bunch of adenine residues form on the template strand of the DNA, and what happened was the A and the U bonds are relatively weak, and it allows for the DNA and the RNA to separate from each other. When it comes to termination using row, the row binds to the mRNA and it keeps moving forward until the end 3 and the RNA polymerase, and then it pauses at the hairpin, and then row has a helicase activity, and that causes the DNA and the RNA to unwind, and it causes the transcription to finally end. Now that I've went over transcription when it pertains to prokaryotes, I have a question for you. Question is, explain the consequences of transcription if the -10 box is deleted in a gene that codes for an enzyme to metabolize sugar. In this situation, if the -10 box was deleted, you would not be able to start transcription, and therefore you cannot be able to metabolize sugar. Thank you so much for joining my lesson. I hope you enjoyed.